Well, please resubmit your quiz number 12 if you have not done so. It's due tonight, 11:59 p.m. So if you haven't submitted, please do. After that, I will not be taking it. Okay. All right. So yesterday we were at basic 19A. Determine the domain and express the domain in inequalities if possible. Okay, the reason we said if possible because sometimes the domain is all real numbers. In that case, you just say it's all real numbers, and there will not be a proper, there will be proper inequality for it. Okay. All right. So let's look at. We did number 4, and we did number 15. Okay, these are typical ones. And we talk about the logic behind it. Every basic function involved must be considered its domain. Okay. So let's look at another one, another pair maybe. Okay, number 3. Okay, we start from something a little bit simple. Okay, so f of x. Oh, we did number 3, didn't we? Oh, we did number 3. So let's do number 5. Number 5 is a function. We call it a rational function. Okay, we call it rational function. It has a numerator. It has a denominator. Denominator is a quadratic. Okay, so let me just make it a little bit larger so you can see the subtraction sign properly. Okay, do you guys see well? Do you see well? Okay, so let me bring up the chat. Okay, to determine the domain of this function, we would look at the numerator and we look at the denominator. Both numerator and denominator, if they stand alone, their domain are all real numbers. But because this quadratic is in the denominator, so we have to make sure that denominator cannot be 0. Okay, so that's the only thing we need to require. So solution. Yesterday, I talked about there are 2 ways of setting up. One is set it equal to 0. One is set it not equal to 0. So these two narratives, okay, I'm talking about narratives. These 2 narratives, they all have its logical narratives in each setup. For example, if I set it up as the denominator equal to 0, okay? So if I set it up as it equal to 0, meaning in our mind, we're trying to identify the numbers such that the denominator is 0 and to exclude them from the domain, to exclude the numbers such that the denominator is 0. Okay, so we have that logic in mind. So if we set it equal to 0, that's what we're up to. Okay, to solve this equation, of course, you can use factoring, you can use completing a square, you can use a quadratic formula. Okay, if we encounter a quadratic, the good thing is that in a lot of academic problems, you encounter a quadratic function a lot. Why? Well, I don't know. It probably is because it's a quadratic. We know everything about quadratic, right? Because we know everything about quadratic. So if you look at this function, it's basically, and you can also use the curve. Right? And we have covered a quadratic. So this is one of those quadratic. If you think, you can think from all different perspectives, right? You can think of this as a function. We're trying to find we're trying to find x-intercepts, right? That certainly is the situation. And f of x is this guy. You can think from that perspective, right? You can think from that perspective. That's certainly one direction. Or you don't have to worry about this, okay? It's just different perspective you want to see, because sometimes you might encounter a function that is not as easily solved. Like in this case, we can just factor, okay? So that's just a factor. So, okay, so we get x plus 2 times x minus 1, and the product is 0, right? And then we get to use a principle number 5, right? Principle number 5, if the product of two numbers is 0. So you think about these principles being used, okay? So if a times b is 0, right? So that narrative. So you will get x plus 2 equals 0. Oops, sorry. Or x minus 1 equals to 0. Okay. And then x equals to negative 2, or x equals to positive 1. Okay. And domain, we will claim the domain would be all real numbers except x except negative 2 and positive 1. Except, okay, here it was or, and here it will be and, because you have to exclude both numbers. Another narrative, another statement for the domain, you just say, x cannot be equals to negative 2, which is the opposite, cannot equals to positive 1, and or turn it into and. Okay, these are actually very basic logics. The opposite of or is and. Okay, the opposite of or is and. So these are the two different ways. And these ways of expressing domain, and there's also another way. By enumerating, by exclusion, by curly brackets, however you say it. So x, and then you put a specifics about x, and then you say x is not equals to negative 1 and negative 2, and x cannot equals to positive 1. Okay, so both must be true. Any number, they have to be in the domain. So these are little simple logic, little details that I put in here. Now let's look at the second way to do it. The second way to do it, the narrative, the setup, of course, is just the opposite of it. Okay, you just go straight to say, okay, the denominator cannot be 0. Okay, so go straight. Okay, this is actually the way I usually use. Okay, if this x squared plus x minus 2 is not 0, that means x plus 2 times x minus 1 cannot be 0. Okay, then we will be quoting the opposite of principle number 1. Okay, so let's practice how to use it. The principle number 5, right? Principle number 5. What does principle number 5 say? Can you guys tell me what's principle number 5? Can you guys tell me what's principle number 5? Principle 5 says if, well, there's different ways of different way of narrative, right? So you can say A times B is 0 if and only if A is 0 or B is 0. And what is the opposite of principle number 5? What's the opposite of principle number 5? Right? Can you guys try that? What is the opposite of principle number 5? So I'm going to show you, okay? I want you guys may not be used to this, okay? But this is something you're going to do very often in calculus. Okay, what's the opposite of continuous? A function is continuous, right? What's the opposite? It doesn't have a limit. What's the opposite? Is not differentiable, right? You need to think of those questions. Of course, you're not going to be thinking about this question. The opposite will be, this is not a 0, and this is not 0. This is not 0, and this is going to turn to and. You guys follow me? In this case, okay, in this if and only if. So the product of two numbers is not 0 if and only if both numbers are not 0. A is not 0 and B is not 0. But in this case, it's or. If one of them is 0, then the product is going to be 0. We don't need to have 2 equals to 0 at the same time. Okay, I hope you guys understand this logic. Okay, so you need to figure out, so to speak, that when at this stage of your study, you have to think a little bit more. You must. Okay, otherwise calculus class is going to be very difficult for you. Okay, you learn a definition or you learn a theorem, and then you're going to have many theorems to learn in calculus class. Okay, calculus classes, I would say, calculus classes. Then you need to think about what's the opposite of it. What if, right? What if? So this gives you a little glimpse of some of the thinkings going into when it's the opposite, okay, the opposite of certain principle. You can think about the opposite of all the principles, actually. Why not, right? Think about it, think about this, and it will be really good training. I would say this training is not only useful in mathematics, it's also useful in other fields. So this will form your logical mind. This is part of to form our logical mind. But anyway, so I'm going to put the narrative together. Okay, so I'm going to put the narrative here, okay? Do you guys follow me? I hope that this doesn't bore you, but this might be new to you. Some of you may feel, oh, why do I need to know this? Very soon, okay, you will, you know, as soon as you get in calculus class, you will have to be able to thinking in this, you know, situation. You have to think about certain theorems, how to use it, you know, what the premises, what the conclusions, what if you reverse them, and what's going to happen. So these are, so calculus classes is not it's not about just taking derivatives. Okay, nowadays derivative can be taken by machine. You don't need people to take derivative for them. What we learn, what you're going to learn is learn how to think. Okay, So this is the situation. This is basically say if, right? If something is not zero, okay? If something is not zero, okay? Then this will be, then A times B is not zero. Not zero. Do you guys follow me? This is logic, okay? My narrative is logical. It's a logical narrative. There are only two kinds of sentences in mathematics. Once you are in the if statement, you'll be doing if then, if then, if then, if then, if then forever until you finish that problem. So simple sentence structure, but it has to be logically built. It has to be logically built, okay? And then if the product is not a zero, then here you can use this guy. Do you follow me? Over here, you're gonna say, if and only if. So this comes to the picture. So then, so the next step will be then x plus 2 is not zero. So you're referring to the A is not zero. Here it's gonna be and x minus 1 not equal to 0. Okay, so if some of you are aspired to take up to discrete math, I don't know what the course number at El Camino, or you might take it elsewhere. It's all about this logic. That course is all about logic. That's the foundation of computer science. It's the foundation of coding. Okay, that's the foundation of coding. Okay, so the opposite of A times B equal to 0 is A times B not equal to 0. And if that's the case, if and only if A is not 0 and B is not 0. So or turn into and, right? You can see that logic. And then you continue to build this, okay? So x is not equals to -2, right? And here you're gonna have the and with you, and x is not equals to 1. You see that how that is built? How that is built logically, one lead to the other, one lead to the other. If there's any broken piece, then the rest is junk. The rest is junk. This is how mathematics is built. This is how mathematics is built. Every step. So mathematics is a training. Okay, I don't know you guys how you guys see this. I'm a person. Okay, my passion actually is not the subject of mathematics. I studied mathematics all that many years ago. And I went to college and I was a math major because I had no other choices. Okay? I didn't have the choice to study the major of my favorite. I didn't have the choice to study my favorite subject. I kind of learned to appreciate it. And in the process, it makes me a little bit more logical. Okay, I think I'm certainly a more emotional person than a logical person. So this is what I'm saying. Mathematics train us to be calmer and more logical. Okay. And there's certain rules, and these rules, if you understand it, it's usually start from simple to more complicated. Okay, like we do this from the truth table, right? Anyway, without further ado, so this if, right? If the denominator is not 0, okay? Denominator is not 0. Then this, then that, all these narratives. So in the end, of course, you get the same conclusion for domain. Same conclusion, just a slightly different narrative. Just slightly different narrative, same thing. Okay, it's really the same thing. So I don't, so when you read mathematics, right? So when I grade your work, when I read your work, and these days, because we're not on site, we're not in the classroom, so I have less opportunity. Otherwise, I give you a lot more, quizzes in class, and I will grade it. That's how I grade your work. I grade your work. If it's if statement, I will read it as a if then, if then, if then. If there's a flawed step, boom, you lose the points. Okay, that's so the way I'm showing you the narrative is the narrative I use to grade your work, is the way I use for, deciding giving you points or not giving you points. Because I'm being trained that way. Okay, I'm being trained that way. Okay. All right, so this is that's number 5. Okay, that's number 5. Do you guys want to try one? How about you guys try number 6 and 8? How about you guys try number 6 and 8? Okay, be careful about your steps and make sure you are in a narrative. In a narrative that you're speaking to yourself, you understand what you're talking about. Okay, so please try number 6, number 8 on your own. Please try. Do you know which one? Do you have the notes in front of you? 6, 8. So G of X. Oops, sorry. Okay, refer to the basic, basic functions, and that's where usually you get the clue as how to set up. When I grade students' work, I will usually look at the setup. Okay, the setup proper. Okay, if the setup is wrong, most likely you're not getting the right answer. So you have to understand the setup. And how do you decide the setup? Well, you just think of the basic function that's involved, right? The basic function involved. Okay, just hold on. Just grab a little. I'm gonna refill my cup just a little bit. I'll be right back. Okay, I'm back. I got the second shot of the vaccine yesterday, and I feel like I don't feel my best. Okay, if I sounded a little bit tired, so please forgive me. And I finished 2 shots. The second shot seemed to have some more impact on me. All right, what did you find? What have we found? Okay, I'm ready to take some feedback from you. If any one of you like to contribute, okay, you can send it to Pronto, and you can also send it to the chat.
So for the first one, you set the equation not equal to 0.
Oof. Okay, so what did you get for number 6?
Um, is it just x squared plus 1 does not equal to 0?
Sure, you can set it up that way. You take the denominator, you set it not equal to 0, and you're going to solve it, right?
Yeah.
That's a good start. And then what? What solution have you found?
So I subtracted 1 and then I square rooted both sides, but it was a negative inside of the root. So I just kind of stopped it.
Hold on. I think I'm gonna need to make the volume a bit larger. Does everybody hear him? You subtracted by 1. I could hear you, but does everybody else hear me? I can hear him, but it's low. Okay. So please, okay. So we subtract 1 on both sides. So we get -1. And then you took square root on both sides, yeah?
Yeah.
Very good. This time is much more audible. Is that the right word to use?
Yeah.
Thank you. Appreciate it. All right, then what?
Then it's x does not equal to I. Is that right?
X. Well, X or X absolute value of X.
Oh, yes.
It should be absolute value of X, right?
Yeah.
Does not equals to I. Then what? Then what you claim to the domain at this point? Yeah? What you claim?
Um,
Because you ultimately want to determine the domain, right? You need to tell the reader what is the domain. Yeah? In fact, all of your operation is correct. But just remember, just be reminded, we are working in a real number. When you encounter a complex number like this, it tells you that it probably tells you something. What does it tell you? It tells you there's no real number solution. Okay, it tells you there's no real number solution. Okay, so if I were you, I'm gonna scribble all of these out. Okay, I'm gonna take a different approach. Sure, you can do this. You certainly can do this. Okay, but as you go down the steps, you realize, you say, hey, wait a minute, I get into the complex number, right? Complex number is not in our consideration. You're not gonna be doing complex numbers in calculus classes for a long time. Okay, so this already tells you there's no real number solution. No real number solutions. Okay, if I were you, I will just toss it. I would toss it, and I will take a different approach. Okay, I'm not tossing it here because I just want to show you these steps are correct, but you don't need to show these steps to your teacher. Do you follow me? Yeah. Okay, so if I were you, I would show work like this, because I realize that I'm getting into, I'm not going to have real number solutions. And then I start to see, you know what? X squared is always greater than equal to 0. Right? And x squared plus 1 is always going to be, it will never be 0. In fact, it's always greater than 0. Can I make these claims? Okay, so I'm also gonna, you know, for any real number x, we have learned this, didn't we? Didn't we learn this? We learned this about this basic function y equals x squared, right? What do you think that range is for? What do you think that range is for? For use. Sometimes you get to use it. Okay, so if you add a 1 on both sides, it's going to be greater than 0. So all you have to do to decide that the denominator is not 0, now it's guaranteed. It's going to be true forever. So what do you say about the domain?
All real numbers?
All real numbers, that's right. Okay, you don't, you know, what I mean is you don't have to rigidly follow the steps. You can create your own narratives. Does that make sense? Because all you want to do is guarantee that denominator is not 0. So if I were you, I would, so this will be the work I turn in. And every professor, I promise you, every professor you're going to see will give you full credit. And you do not need to show this at all. Okay? You don't do this on the scratch paper. That's why when you do math, you always have scratch paper. You scratch all over the paper. Some are useful to you, some are not useful to you. So you guys, you're going to discard those not useful for you. You just use those little parts that's useful for you to make your point. Okay? You go straight to the point. Go straight to the point. Do you follow me? You go straight to the point. For example, let me give you an example of, suppose you are a lawyer, okay? I mean, this story is evil, but it happened to me, okay? Someone, a lawyer, wants to prove that I am not an honest person, okay? All my life, I want to prove I'm an honest person, right? So here comes a lawyer, wants to prove I'm not an honest person. So this is how this lawyer proved that I'm not an honest person. He says, You know, she's very honest with her neighbor, and she's very honest with her student, and she was very honest with her families and all of that stuff. And after all these narrative, and she said, well, the lawyer says, well, you know what? She was not honest with her classmates 20 years ago. So how do you feel about the effectiveness of this lawyer to prove that I'm not honest? Huh? I would say this lawyer is very nice, right? He has demonstrated that I was honest here and there. I was honest many, many times, but I wasn't honest with one of my classmates many, many years ago. How would he prove my dishonesty more straightforward?
With an example?
Just give that example. 20 years ago, I was dishonest with my classmates, isn't it? He doesn't need to enumerate those other cases that I was honest. Yes? Because you need to know what's your point. Your point is to prove I'm dishonest. Okay, of course, I don't like this topic, but I cannot make any joke about anybody else, right? So I'm making joke about myself. So do you understand what I meant? You need to understand what's your point. Your point is to demonstrate, you know, this person is not honest. You go straight to the example that she's not honest. You don't need to enumerate, oh, she's honest here, honest there, honest there. No, you don't need to. Go straight to the point. Okay. All right, do you get it? You go straight to the point. That's in mathematics. Okay. In real life, there are other sayings, but I'm not talking about real life. I'm not talking about real life. Okay. Real life can be more cruel. Okay. And they use the word saying go straight to the blood, right? That sounds very bloody. That sounds very bloody. But some people do that, you know? So I was just trying to make a point. I was trying to make a point that you go straight to the point. When you try to prove something or demonstrate something, you don't need to take those sidetracks, you know, you don't need to do those sidekicks. No, you just go straight to the point. Now, well, that's why you need scratch paper, right? You need scratch paper. You scratch this out, and then you realize, hey, this is not useful. I have an idea. This is maybe better. Is this the only way to do it? Of course not. You could have said this is not zero. That's also sufficient, excuse me. You can use this statement as well, and everybody will have agree with you, right? So you can use that. Okay, you can also say, oh, x squared plus 1 will never be 0 for any real number x. Therefore, the domain is all real numbers. Did you see the flexibility you have? You have lots of flexibility. So now let's look at this one. This one, you may like to follow the routine. Because this one, you do need to do it, okay? You will set up the denominator equals to 0 or not equal to 0. Which one do you prefer? You know the narratives are different, right? So suppose I use not equal to 0, right? And then I'll be using the if and only if, right? The if and only if. So these things are in my mind. Okay, these things are in my mind. You don't need to write it down. You really don't need to write it down, because whoever reads your work probably know what you're talking about, but you have to set yourself a stage for your narrative. And then what you do, you will factor. Okay, that's not equal to 0. Okay, and then the other narrative will kick in your mind. The other narrative will kick in your mind. Okay. These narratives I put on the side. It's not something you have to show your professor. You don't need to show that. I'm showing you because I'm doing the lecture. Okay. For your note taking. Okay. You don't have to show this. But if you show it, make sure you show it right. Okay. That's another thing. If you show it, okay. Some people like to say, oh, I'm going to make sure I get all the points. I show it. If you show it, you better make sure you get it right, because if you show it, we will read it and we will judge it and we will decide whether we'll give you points or not. Because we're assessing you. We are in the position to assess you. Okay, so without further ado, the bottom line is that you are being assessed, and every opportunity we have, we assess you. Oh, sorry, this is not equal to 0, right? Over here is x minus 1 is not equal to 0, right? So you want to be consistent with your narrative. If you use the equal to 0, you use equal to 0. If you use not equal to 0, you use not equal to 0. So in the end, right? In the end, we get x is not equals to 1 and x is not equal to 0. So the domain will be formed. Domain. Okay, there are 3 ways of saying it. All real numbers, but x is not equal to 0, or, all real numbers. So that narrative, right? So I'm going to copy and paste those narratives so you can see the consistency. You can see the consistency. Okay, I want you to see the consistency. Okay, all real numbers except 0 and 1. Not equals to 0, not equals to 1. Not equals to 0, not equals to 1. Do you see that consistency, that narrative? It should be very clear in your work as it's clear in your thought. Okay, so your work is a reflection. If your work is a reflection of your thoughts, we cannot go in your head to think, to figure out how you think, right? We cannot do that. So we can only assess your work. We can only look at your work and assess, did they think correctly? This is logical. Is this step from this step to the next step, is that logical? What does this step mean? What does this step reflect the student's understanding of the topics, right? That's what we do. That's what we do. That's our job. Okay, so number 6 and 8. Now I'm going to give you a bit, so next we're going to look at 11 and 13. 11 and 13. Okay, these questions are a little bit more interesting, right? So let's look at number 11 and 13. Number 13 actually was a question. I will tell you the source of this question. I have a friend and he teaches at a 4-year school. And that's his exam question to his student. And I thought, oh, that question is pretty good. I like it. So, but this question, he put it in his calculus class. Okay, so what we do here to determine the step is just the first step of that calculus class question. Follow me? It requires some algebraic skills. It requires some knowledge about domain and range for the basic functions, and also requires you to operate and manipulate with exponents that are fractions. Okay, exponents that are fractions, right? if you want to practice some more about these, and I think in our earlier homework, I have given you those sections like basic 21, 20, 22, and so on and so forth. And those exercises in those sections will give you the opportunity to practice. But if you don't use my notes, you can just go to any intermediate algebra textbook and pick up those operations on roots, or when the exponents are fractions, which our students are often very confused about them. Why are we confused about them? Because we didn't do enough exercise. That's all. That's a diagnosis that works for everyone, I believe, for most people. Okay, if you didn't practice enough, of course, when you see those questions, we're gonna practice these basic things. Okay, so number 11. Have you started? Go for it. G of X G of X minus 3X minus 10 . 13 is f of X . The setup, right? Let's look at 11. How would you set up? Obviously, on the question of 11, okay, you can see it's a combination of two functions, right? It looks like rational, but it's not rational because in the denominator you have something like this, omega. Right? You have that situation. Then you say you know the domain, right? So you know the domain. So you really could see this as two functions. One function is that, and the other function is I can put I'm gonna put something like a heart. Okay, you see this basic function, right? That's one of the functions in basic 1, and this is another one basic function in basic 1. So when you combine these two, what do we end up with? Well, denominator cannot be 0. And what's in the denominator? This guy, right? Domain is greater than or equal to 0. Range is greater than or equal to 0. So when you set up, you will set the omega to be what? Greater than 0. It cannot be less than 0, yeah? Because less than 0, you're taking square root of negative numbers, right? So you have to consider both situations, right? So in this situation, the heart cannot be 0, right? In this other situation, omega has to be greater than or equal to 0. You combine these two. Do you guys see the symbolic considerations that you mind vision? Our mind vision these two functions at play. Okay. And then that's the consequence. So that's the setup. This is setup correct. This setup will satisfy this condition. It will satisfy this condition. Both conditions must be satisfied. So you need to have an and in between, logically. Okay, you need to have an and in between. right? On the one hand, you have to guarantee, oh wait, I should put the end right here. Do you guys follow me? Okay, it's actually two functions at play. Okay, two basic functions involved. And you know the domain of the basic function. This exam, this midterm exam, right? We studied basic one extensively, didn't we? We graphed every function, almost every function, but the simplest ones. Domain and range will be asked of you. You need to know the domain for all those trig functions, all those, root functions, rational functions, logarithm functions, exponential functions, all of them. You need to know them. You must. Okay. All right. So these are the thoughts that go into our setup. Okay. But in your setup, you just have to show the word solution. Okay. So this is how you show the word. Solving this equation. Doesn't this equation look like one of those in basic 9? Doesn't this equation look like one of those in quadratic? So now you know how to do it, right? We have so many ways to do it, right? You can do the graph, you can do the sign, you can do all sorts of things, yes? So now I'm going to give you a couple minutes to work on this. So now do we agree that basic 9 is really, really basic, isn't it? Basic 9 is really, really basic. But even when you're doing calculus classes, over time, from time to time, you will encounter these situations, which is a basic. Okay, I'm ready to take a look of anybody who wants to share his work. We've been very, very good, and I'm very, very grateful for those of you who contribute to the classroom activities, okay, by showing your work. I immensely appreciate that. Okay, that makes the class teaching much more interesting. And I feel like I also can see that the things you've done right, the mistake you make, and oftentimes those are common mistakes, so we can correct them right on the spot. Okay, so think of the method we learned before. Okay, think of basic 9. Okay, quadratic, etc. Those ideas, okay, how do we do this? Right, we have multiple ways to do this. You just have to choose one way to do it. Right, you just have to choose one way to do it. I don't know if anybody have taken a look at basic 19B. Okay, I can promise you right here, right now, that 99% of these questions in 19B will show up in your calculus class. Okay, because they are all taken from there. Okay, I went through lots of books. And of course, I went through your calculus textbooks to pick up those questions. All right, what'd you get?
Can I send my work on Pronto?
Sure, yeah, that would be great.
Okay.
Love it. Okay, I'm gonna open the Pronto. I love that. I love that. Okay, I really appreciate you guys send the work to Pronto. Okay, it's a great contribution to the class. It's always very helpful. I know it takes some courage, right? It takes some courage. Yay, I got it. Good job, Cortland. Thank you so much.
For that one, I just did the quadratic formula. I didn't know how to actually say the answer.
No problem. You have so many ways to do it. Do you guys know that you have so many ways to do it? I cannot run out of ways to do it in class. If I want to cover every method, it's going to take the rest of the time of the class and more. Okay. But I hope I could inspire you to think all those things you can do. Okay. So hold on. Let me see if I can find. You have sent it, and I hear it. Let me. Oh, there. It comes. Wait. There. Sorry. I have two screens. Sometimes I don't know where is it? Where is it? Okay, so I'm gonna download this picture. And if anybody else would like to show your work, please do it by all means, okay? Don't you love Pronto? I think Pronto is great. Do you agree with me? This is a great way of, do you guys see the screen? Right here. Does everybody see this? Yeah? Wait, too big. Let's see what he did. Okay. And I'm so delighted to see another way of doing it. Okay, I'm very, very delighted to see it. Okay, so he was trying to solve this inequality. Okay. And then what he did is that I'm gonna, along the way, I'm just pretending I'm grading your work, right? And
Yes. Yes.
on your work, obviously you're doing the quadratic formula. Okay. I would prefer that you tell me what you're doing here. Okay. I would prefer you telling me to do this. I know what you're doing, but I would like you to tell me what are you doing here.
Like, did you want me to, you wanted me to write it out on the paper, or you want me to tell you what's going on?
Well, at this point, please tell me then.
Okay. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2. So I just inputted
Okay.
those numbers into that equation, you see.
Very good. But you did not tell me what are these numbers for. That's what I'm asking. What are these two numbers for?
And right, that's what I was stuck on at the very end because I didn't know how to say that.
Okay. In my view, you're trying to find the x-intercept. Okay, this function is x squared minus 3x minus 10. This is the function, isn't it?
Yes.
You're trying to find the x-intercept, or you're trying to, you're saying, okay, I'm setting this equal to 0, right? And the solution you're getting. So you would like to have these equal signs there. Do you follow me?
Okay.
Okay. So these are the narratives. You're looking for solutions. Okay. Don't use these arrows, guys. Please don't use arrow. Okay. Over here, actually, I'm going to remove this. And you use arrow. Don't use arrow. I would use x sub 1 if that's That fits your intention. And then this will be x sub 2.
Yeah, that's what I was trying to do. That's fine.
Yes, okay. Sorry, this is misplaced. Okay. So you want to write the bottom line. I will rewrite it on my screen, but I just want to show you that how you properly demonstrate your work. Okay, I know a lot of you understand the concept, but you have to know how to properly demonstrate your work. So here you're gonna use equal sign. Right? I really appreciate this contribution. It's great. Okay, so you're doing you don't even have to introduce that one. You don't have to even introduce the f of x, but you're telling the reader you're finding solutions to this equation. Is that what you're doing?
Yes.
See, then you tell the reader. You tell the reader.
Okay.
Okay, you tell the reader, and then you found these 2 points, and then what else are you gonna do? Because you are basically present a context for reader to understand you. Do you follow me?
Mm-hmm.
So when people read your work, people read your work, say, oh, what is he trying to do? Right? So you must know what you're trying to do. Yes. So you are the guide. You are the leader in this. You are the leader in this. So you're going to take charge to explain to the reader, this is what I'm trying to do. Okay. I'm trying to find the solution to this equation. And the solution to this equation is really the x-intercepts of the function, right? Because here the reader will say, well, we will ask you to solve this equation. Well, this inequality, we want to be greater than 0. Why all of a sudden he make it equal to 0? Why do you make it equal to 0? You have to build a context. Sometimes you have to say a few words. Okay, you have to say a few words about it. Okay, so next, does everybody understand? And your work here is a very good job, but it will be viewed as incomplete. And I imagine you're actually going to do more after this. Is that right?
Yes, indeed.
Yes, indeed. Okay, very good. Okay. So because we're in a classroom setting, and I really appreciate this, and this is the kind of work I see often, but you just need to put some bits and pieces there to make your work whole. Okay, so now would you allow me to demonstrate how I would show the work?
Yeah, good.
Okay, thank you for your contribution, Cortland. I really appreciate it. I think you did a very good work. All right, so I'm going to put this away. Okay, and I'm going to go back to here. Okay, so I'm going to build a narrative. If you decide to use a quadratic rod, right, you can use, if you use a quadratic rod, then you're going to tell the reader, okay, find solution to that equals to 0. Okay, the reader started, oh, he's or she's trying to find solution to that equation. Okay, to solve this, of course, you can do by factoring, you can do by quadratic formula. So I'm going to use your quadratic formula. Okay, I think you're using quadratic formula is a great idea, because when you use a quadratic formula, you can always find the solution regardless, right?
Yep.
Factoring is not always possibly done easily. I mean, factoring, there are always factors, but you may not find the factors easily. Okay, but quadratic formula, yes. Okay, so I'm going to borrow yours. In fact, I'm looking at your work, and I'm going to copy. At the same time, I'm checking your work. Okay, so the work you show there is negative or -3 plus minus, and this is the square root of b squared. You have a -3. Your substitution there is superb. Okay, you have all the necessary parentheses there. You have 4 times 1 and times -10, right? Yeah. And 2 times 1. So that's 2 times 1. 2 is fine. Okay. And then you go ahead, you say, okay, x equals to that, right? And then your next step, you're saying 2 is underneath the fraction bar. So you have a 3 plus minus square root of, I'm just going straight to 49, okay? Which is correct. Okay, so in the end, almost to the end, you're gonna have 3 plus minus 7 divided by 2. And then you're going to say, okay, because you have a title here, right? Find solution to this equation. And this equation is x sub 1. Oops. X sub 1 would equal to, you got negative 2. You use 5, right? Okay, let's use 5. And x sub 2 is equals to negative 2. Okay? And what are these? The next thing, you will sketch. If I were you, I'm just following your ideas, okay? I'm going to sketch this curve. Okay, you don't have to be perfectly, it doesn't have to be a perfect curve. You're sketching this curve. Do you guys follow me? You can just totally sketch it on your paper. Okay? And of course, you know what to sketch, right? If I do a sketch, I would just do this. Okay, I would just do this. Boom. I will be doing this on my paper. Do you follow me? Because I don't want to give you the impression that it has to be perfect. It doesn't have to be perfect. Then I'll be marking these points. One is negative 2. Oops. Negative 2 comma 0. And the next point I'll be marking, which is a 5 comma 0. I would just sketch something like this. Do you guys follow me? If I turn in my work, I will sketch something like this. And that should be perfectly okay with your professor. Yes? Okay, I'm trying to show you a nicer work, which by typing and using the software, but you can just show something like this, okay? But anyway, so next, I want you to work with me. Okay, I want you to work with me. I'm going to mark these 2 points with dots, right? You know how this goes, right? 5 comma 0. Actually, it should be circle, isn't it? It should be circle because we want it to be greater than 0, right? So you'll be prepared. So you get 2 circles here, and I will also make some adjustment for my curve, so that I will see more of the curve. That should be enough, right? So which you can see, this is the sketch I meant. Okay, this is the sketch I meant, and this is of course, I in the classroom I have the convenience of doing that, so I did. You follow me? But on your work, you just show that piece. You just show this piece. So your reader will understand the reader is following you, right? The reader is following you, and you sketch that curve. Okay, and you are going to mark those 2 points. You are going to mark those 2 points. Are you following me? You're going to mark these 2 points on your picture, like what I did earlier. Okay, so I'm marking those 2 points. I'm a little like a perfectionist, and I want to mark it nicely since I give you the picture. And I will add another point for 5 comma 0. Right, so 5.2 and over here. So are you guys marking your points? So you take your time. You do take your time when you work these questions. You go through this process. Boom, I have these 2 points marked. And what do you do next? Right, so you can see you don't have to do this perfect picture here. You just show something like this. Okay, and then on your paper, you will say, oh, this is a positive. This is a positive. Okay, this is a positive, and that's negative. Got it? And I'm going to, of course, I'm going to erase all of these. This will not be necessary. Okay, then your reader will realize, oh, you can, this student found these 2 points of, x-intercepts, and then he's demonstrating that this part, the function is positive, this piece of function is negative. So naturally, you're going to tell the reader the solution, what will be the solution here? You want it to be positive, right? You want it to be positive, so what you get? You get x less than -2, or x is greater than 5. So you're building your work. You're building your work. Okay, so now I'm going to give you the whole of it. Would you like that? I would like to give you the whole of this piece of work. Do you see it? Do you see the whole of it? Yes? Yeah? Do you see the whole of it?
Yeah.
That's what I want you to see. The whole piece of your work you turn in will be something like that in writing. If you choose to go this route, I mean, you don't have to do the curve. You can do the sine thing, We learn so many methods. You can even use completing a square. There's so many fancy ways to handle this, and we have to review them all. Okay, in particular, and I'm so glad that Cortland thought of using quadratic formula. Quadratic formula is very, very useful, but you must know what you're doing. You're trying to find x-intercept, right? You're trying to find x-intercept. It's about that function that x-intercept means the input is to be found and the output are 0. You follow me? It's all about, that's what I said, it's all about input, output. Do you agree? Different rules. It's all about their input, output. That's all you do. Got it? So this will be a piece of work. Not the only way to do it. Okay, as I said, it's not the only way to do it. There are many other ways to do it. I'm not going to enumerate them all. Okay, but we want to get to number 13, don't we? Right? You guys probably were intrigued as that is a test question by a professor in a 4-year school. You may wonder, which school is that? Is that where I'm transferring to? You never know. Maybe. With that professor, when I saw that question, I was telling him, I said, this question is hard for our student. And I said, could I use it? And he said, sure, go use it. So I decided I'm going to use this. This is a calculus test question. So I'm going to make it a practice in my students' class. Hopefully when my student encounter that question, they know what to do. Okay. All right. So without further ado, are you ready? So once again, thank you for your contribution. Thank you for all these discussions. So feel free to explore other ways of doing it, okay? We just don't have time to do it all in class. Okay. Get your scratch paper ready. Okay, so I'm gonna work on my scratch paper. Okay, I call it think out aloud. And I'm gonna make the fonts a little bit larger because I want you to see the negative sign. Do you guys see the negative sign here?
Yeah.
I wish to tell you, you're gonna see a lot of these questions in your calculus class. Okay, you're gonna see a lot of similar questions, even though it may not be this one exactly. This one actually is simple looking. Okay, if you flip through the notes I have given you, the lots of sections which I took from calculus class. Some of those are exercise, I work it out, and you need to simplify. I will tell you where they are, okay? It just require a tremendous, I would say, a lot of algebraic familiarity. Okay, so how do I do this? There are two different approach. One is using the root form. Okay, so I'm going to use the root form first. Okay, I think the root form might be something you are familiar with. So if you use the root form, it's going to be something like this. It's root 3 of x, but it's in the denominator. Do you guys follow me? I hope this is not too weird for you. It's basically b to the power of negative n is equals to 1 over b to the power of n, yeah? We know that, don't we? And this other one, and of course there's another thing, is that the root, okay? So suppose you have an m and you have a bologna here, okay? Raised to the power of n, right? What is that? This is really the omega. Okay, I'm just helping you to review this, okay? Review this. And the root number, m, is the exponent and in the denominator. And the numerator here is the n. You guys follow me? Remember seeing this somewhere, somehow? You're going to see a lot of those in Cal. Because if you don't see these, you're going to be, working with trigonometry. That's a major difference between 190 and the business calculus. Okay, business calculus, you don't have to deal with trigonometry, but you still have to deal with these. Okay, in STEM calculus, you have to be able to deal with this, and you also deal with the trig and exponential and logarithm. Okay, you cannot run away from it. Well, if you want to run away with it, you may just not taking that class. But I want you guys to face up the challenge because you can do it. You can totally do it. Okay? So what I'm doing here is that here, I can write it in numerous ways. I can write it as root 3 x to the power 5, right? Because this is a root 3, so I can also take the 5 outside. Do you follow me? Do you guys follow me? So symbolically, so what are you actually working with is 1 over b minus b raised to the power 5, where that b is this guy. You guys see that? Yes? Does it still look more frustrating anymore? I hope it's a little bit better, right? Is it a little bit better?
Yeah, it's a little more simple.
It's a little better, right? So you just have to work it through. Grab your scratch paper and work through it. Okay? Do we know how to simplify this guy? Common denominator, right? The common denominator obviously is b, right? So I have a b to the power 5. In order to get that common denominator, I just have a b over b. Okay, remember in the whole process, we're trying to determine the domain and stuff. So we're going to come back to it. Okay, so this will turn into what? We have the common denominator. We have a b in the denominator. On the numerator, we get a 1 minus b to the power of 6. Does everybody follow me? You must do it, okay? You must do it along with me, okay? You have your paper pencil with me? Do you realize you can totally do this? Right? If you practice 10 more of these, then this is piece of cake, isn't it? Piece of cake. Now, we still have to bring these back, don't we? So we're going to bring them back. Okay, we're going to bring it back. Okay, we bring it back, no problem. Okay, I'm going to bring it back. Right, I'm bringing it back. I'm going to bring this back. How does that look? How does that look? How does that look? Do you follow me? This is algebra. This is entirely algebra, right? It's basically series substitution, right? So then we don't need this anymore. Does everybody follow me? You are going to see a lot of these weird things in Cal. Okay, I don't want them to look so weird to you by the time you get there. So do something before. Do something before. All right. Now the question is, what is this guy equal to? What is this guy? If you use this guy, if you use this relationship, you will find that this is just x squared. Yeah? That is just x squared, isn't it? Because it is equals to x, okay, root 3 of x, right? So let me give you just a few more steps. X raised to the power 6, right? And that's going to be x raised to the power of, oops, x raised to the power of 6 over 3, and that's x squared. So in the end, what do we get? All right. So you may want to know that story. After I took this question from this professor who teaches in 4-year school, you may wonder, how did his student do? Did you want to know that? Do you want to know that? And, you know, I happened to see that he was grading his students' work, because that's how I spotted. That's how I spotted. Not very well. Not very well. Some of them made a mess on their test paper. Okay, of course, the privacy issues, I'm not going to give away anything. It's just a lot of students just cannot handle things like this when they're in calculus class already. But if you calmly deal with it, is this very, very difficult? Is this something beyond you? Of course not. This is not something beyond you. This is something you can totally do. Every one of you can do. Yeah? All right. So now we're still coming back to determine domains, right? We're coming back to determine domain. So how do we determine the domain? So now I'm going to show you the work. Okay, solution. Okay. When you do this solution, you just, you know, we already have these nice, you know, okay work on the, you know, on this. You don't have to show your professor these. You don't have to show your professor that. And you just go down the steps and you tell the professor that the denominator, this is a basic function, root 3 over x, root 3 on x, right? Cubic root of x. So what's the domain? That's one of the basic functions in basic 1, isn't it? What is the domain?
All real numbers?
All real numbers. Now it's in the denominator, therefore it cannot be equal to 0. So the domain is x is not equals to 0. That's it. All real numbers but 0. All real numbers but 0. Yeah? That's it. You're done. You're done. So next, with the remainder of the time, we have 8 minutes. I'm going to show you another version of doing this. This time, okay, I want you guys to be very involved. This time, instead of using the root symbol, I'm just going to work with exponents. I'm just going to work with exponents. Okay. A lot of our students are very intimidated by fraction. And they were even more intimidated by fractions in exponent. Oh my God, that's terrible, isn't it? But you can totally do it. I want to show you how you can do it. I want to show you how you can do it. And you will, once you do it, you follow my examples, and then you do it a couple of times, and then it will be totally yours. This technique, this skill, this algebraic skill will totally be yours. Okay, you just need a little bit more practice, kids. Okay. Okay, that's all you need. That's all you need. You just need some more practice. Okay, a few less parties. You make it. You make it, right? And you can party all you want after you get into that nice job and a wonderful career. All right. What do we do? Okay. This piece, and of course, it's going to be about these using these properties. Okay, b to the power of m multiply b raised to the power of n equals to b raised to the power of what? M minus n, something like that, right? Yes? Oh, plus, sorry, plus. Yeah? And there's a subtraction of it, right? There's a b raised to the power of negative n equals to 1 over b raised to the power of n, right? All these things that we learned a long time ago, but we may not have practiced enough with fractions as an exponent, right? So let's get started. If I am to operate with only exponents, okay, one of the other things you might see in the literature, in the textbook, okay, they will do this, okay? They will do this, negative 1/3, okay? And they will put a parentheses, 1 minus x squared. Literally, if you look at any textbook about this question, that's all the work they show. That's all the work they show. Okay, if you find a textbook that give you more steps, please let me know. That's all the work they show. What have been done? When you read this and when you read this, you say, what the hell? How did he get there? Right? Would you be asking that question? How did he get there? Okay, so I'm going to insert a step. Okay, and I make a claim that there's more than one way to do this. There's more than one way to do this. What this author did is that he put this here. Obviously he tried to factor this out, right? And he didn't have this. He has this. This is obvious, but he didn't have the same thing in here, right? He didn't have this thing here. And he needed this thing here to factor out. Yeah? But he cannot just put it there. So he has to make what? He has to make, wait, okay? 1. He has to do this. What is this guy? Could you guys put it on your scratch paper and operate on this one? What does this equal to? x to the power negative third multiply x to the power third. You follow this rule, what you get? You get x raised to the power of 0, and that equals to 1. Do you guys follow me? That's all they did. And the textbook probably will skip this step. Okay, the textbook will skip a lot of steps, tell you the truth. And these skipped steps had to be filled by us, because otherwise you lost. You cannot reproduce it, right? You cannot do it. So when you read a mathematical textbook, you have to spend a lot of time to figure out between these steps. They might have skipped 5 steps, 3 steps. Okay, do you follow me? And now you have that guy, because what did I do here? This is 1, right? So I basically multiply it by 1, yes? What did we learn about that mathematical principle? Anything times 1 stay the, anything times 1 stays the same. Why do we want to stay the same? Because we're handling a statement. You cannot change this statement. You cannot change this rule. In other words, you cannot change this rule, period. So you can only multiply by 1 or add a 0. Do you guys follow me? So we're back to principle number 1. Everybody? Now with exponents, sometimes this is very useful. So now we can factor out this guy. And we have a parentheses, and we have a 1 minus these two together. Right? What you do? You use this guy, right? You add 1/3 with 5/3. Do you follow me? Do you guys follow me? And what you get? 1/3 plus 5/3.
X to the power of 6/3.
That's right. And power of 6/3 is what?
Power of 2.
That's right. Right? So 6/3. Do you think you can do this? I totally believe you can. I totally believe in all of my convictions you can. Maybe in your past experience, you haven't had a time to do it. Now it's time to do it, okay? So I'm gonna point to some places you can practice this, okay? I'm gonna point to some places you can practice this. Okay, as I said earlier, I've given you a lot of exercises, and I believe these practices, let me point to, okay? Because we may not have time to do it in class, okay? But if you have any questions, feel free to ask me. That was in the place of basic 21. Throughout, I have given you that homework before, right? You also see these work being given to you. At a basic 39B, I really put a collection of lot of work if you wish to practice your skill. So you don't have to buy a new book, you can just simply practice with these exercises. If these exercises not enough, find more, okay? Find more, go to a yard sale and pick up some textbooks. Hold on, I think I have a basic something. I'm gonna find it. This is the end of the class, but I really want to tell you where to find those work to practice. Okay. And those exercises, and I'm gonna tell you. Isn't that exciting? You get to practice some more. Yes, is it exciting? I know sometimes you feel dreaded about it. Okay. I want to tell you where to find it. Basic 45A. Basic 45A. Okay. Okay, so I'm going to put it on the top. For more practice, okay, go to basics 45, A, B, and so on and so forth. These questions, let me tell you about these questions. Okay, these questions actually, I 46A, okay, 46B, and C. Recommend it. We may or may not have time to do it in class, but I assure you, you're gonna meet many of them in your calculus class, okay? So let me tell you how I created these questions. Some of these questions are copied from calculus textbook. Some of these questions is that I took the calculus textbook and I did the derivative and I created that question. Okay, because I taught calculus class before many times. So I found my students have hardship with simplifying those, derivative they have found. So I created those questions that way. Okay, so it wasn't my originality. It was just, I take a question from calculus classes and I take a derivative and then I put it on the exercise for you. Just to enhance your algebra for that purpose, Okay, so these are the sections you can find. Okay, I'm not saying you should do all of them in one day, but do a few of them every day. Or, when you have a few minutes waiting for someone in the car, just do it. And these will enhance your algebraic skill. This will enhance your algebraic skill. And the consequence is that you're going to have better grade. All right. So without further ado, I'm going to put this in the homework recommended section part. And I will see you guys tomorrow. So please don't forget to submit your quiz number 12. And I apologize for that loss. And I didn't know what happened, how was it technically lost. But please do submit. Okay, tonight is the last is the last moment. Okay, it's the last day. Today is the last day to submit. Okay.